Okay, hey there. I'm just doing a quick walkthrough here of the Asteroids in C Sharp project that I just created and posted up on GitHub and also Sourceforge. Uh, there's a lot of things that I did, ended up, to put this together and everything, and I just wanted to, basically go through it real quick and just explain some of the decisions that I made and everything with it. So, anyways, without further ado, I'll get started into it. If anybody's ever done a code walkthrough, basically all it means is going through all the files that are involved in this project and more or less explain the logic and rationality behind it and why the programmer did what they did. Now, keep in mind that this was taken from the original it was modeled after the original Asteroids game 1979 that came out published by Atari. So I was trying to do a picture perfect rendition as much as possible and also do it without leveraging any dependencies. So that means no no external libraries, no nothing. Strictly C Sharp .NET code with this. So first let me show you how this works and everything. I'm just going to hit F5 here in this window and show you real quickly what the end product is resulted in, what I've created here. So this is just the opening screen. There's no high scores listed yet. And here's a quick little playthrough. I might need to. That's normally not supposed to happen, but so you use on the arrow key up to thrust, left and right to rotate, and then hyperspace is by pressing down. So it needs a little bit of work still, but the core functionality is there. I'm pretty happy with how things have ended up, and as you can see, I've got a score there too. So I'll be brushing it up and just doing a little a couple little things to it, and might be polishing, I should say. And yeah, so anyways, there's three. There's basically you've got a primary component, the form. Form doesn't have anything on it. That's it right there. So we've got a timer and we've got the form. That's literally it that's going on here. And I'm doing everything in the project through line drawing. And I've got a couple different objects, if you look over here off to the right hand side, that are more or less the game assets. So normally these would be contained within a resource file. So for instance, vectors, the model for a vector might actually be contained within an external file that you pull in, or the assets might be contained within a texture bitmap. And I avoided all that. I wanted everything completely generated, including, if you take a look here at the font handler, I hand drew all of the fonts. So that way there's no licensing issue, there's no problem, and each one scales too. So in any case, coming back over here to the primary form, here's the primary entry point with this, and there's the form. And what I do is don't do anything too crazy. I set up the ship right there, and that's just going to be the player ship. Create the scoreboard, and the scoreboard's going to be the stuff in the upper left hand corner, the top, and also keeping tabs on anything that the player hits. Create a list of projectiles that are being fired at this moment by the player, and then projectiles that are fired by the UFO. And the UFO has a separate class in itself. The high score entry screen gets initialized here, but it doesn't get used until later. And then I've got a sound library right here. And I initialize the UFO position, like I said, to remove just for testing. I'll remove that later. And from there, I create the demo screen. So this right here just contains a number of different asteroids. Each one's going to be, different sizes and everything. So if I take a look at that and what the initial screen does, you see that got all these different asteroids that are floating around at random directions and everything. That's created by this loop right here. So this right here is the primary game loop. So what I do is I have a single timer over here. If you take a look at this timer, and got the interval set to 30. So what I'm doing is rendering this at basically 30 divided by 100 frames per or 1000 frames per second. So that's equivalent to, we do the math real quick, calc. I'll come up with a precise number here. 30 divided by 1000, 30 divided by, or 1000 divided by 30. That's not right. Yeah, so it's about 33 frames per second is what we're running at this point. And I just wanted it to run, as close to 30 as possible and everything. A nice round number. So with this right here, I've got a main ticks that I use here to basically count down the for each sequence of events and everything. Ticks is extremely important. Now, if you're not familiar with ticks, it's a lot more granular than the millisecond. It's a counter that allows you to look at the nanosecond level of how quickly things will get processed and everything. So I'll get into that later because ticks are pretty important. But with this code here, without getting too much into detail, is when the player is playing. And so as you can see, I have a switch, a boolean right there, that actually says, is the player playing and is the game still not over? So this is the main loop. And with this, we do a check to see if the count of asteroids that's actually currently on the play field is greater than 0, meaning the player has not cleared. And like this says right here, players playing the game begin transition from demo mode to play mode by clearing the field. So at this point, if it's greater than 0, meaning I've actually at this point pressed number 1 on the keyboard. So just to show you where this gets executed. Right now, I'm going to press on the number 1 key. And that's where that gets initialized. So the player's score gets set to 0. Now what I'm going to do is actually look at the ticks to the start. So if I actually look at that value, go down here. So right here, the ticks to the start gets initialized with the start of the game, how long it's been since the player has actually physically started this game. So when I press that 1 key, it switches the player to basically say we're playing. We indicate that we have 3 ships left. It's currently hard-coded at that. There is no bonus score or anything like that to actually give you 4 ships, and we can toggle this if we want to make it, I don't know, 5. So if you actually watch it get played now, you see that there's 5 up in the upper left-hand corner. So I can toggle that at any time I want to. Change that in here in code. Let's make it 10. Got a lot of ships up there now. But 3 is what the standard arcade version does. So again, the ticks to the start tells me this level and this game has started at that point. So if you look at ticks to start, we've got right here, that tells me we're looking for this to actually wait 2 seconds after this code gets executed. And at this point, we're actually toggling the variables on and initializing some things, like basically saying, okay, got an ambient accelerator, which is the used for the background music to more or less say at one speed, the music's playing at a normal basis. The lower that accelerator goes, the higher, the faster the music will play, the little boop boop tones that go in the background. The next random UFO encounter is calculated at this point. It's going to be from 5 to 15 seconds based on the on this time. So when the game starts, we can guarantee that that UFO is going to come within 5 to 15 seconds. Now, all this is taken off of basic timings that I've eyeballed completely by watching gameplays on YouTube and that kind of stuff. And then I got the load asteroids for this level. So if we go take a look at that function, at level 1, we've got the main scoreboard has the current level with it. We have 4 asteroids that are going to get played. And then again, I eyeballed the games that were played. 6 for the level 2, 8 for level 3, 9 for level 4, and for 5 and after, for 5 it was 10, and for anything above that was 11. There appeared to be a plateau. And that's going to populate the initial field in between levels with the number of asteroids that are actually going to be on that field. And you can see this. I'll just go ahead and start it. Boom, you got 4 right there. So next thing that we check for is the player hyperspace. So there's a key down hit that's actually hit later. And I'll show you on the keystrokes. So I'm doing this all in the game loop to make it a little bit easier to know that these are the things that are going on the screen on the game loop. So with this right here, you got the player hyperspace. If I can go back again, key down. Look for the key down key. Is the player active? I want to make sure we're only doing this when the game player is playing the game. At that point, we toggle that switch, and at that point I acquire a timer for how long it's going to take for this player to actually come back from hyperspace. And I'm calculating it to be anywhere between 0.5 seconds to 2.5 seconds, which is what I witnessed in Asteroids games online. Again, I'm comparing all this to what I've seen online on the YouTube videos with the official gameplays and everything. And if the player is not active, then at that point process the key differently. Now, if the player is actually entering a high score, that down key works a little bit differently. So that actually acts as a character enter screen. So when they're entering their initials, like I just did, Q, and all of a sudden, here, I'll show you. I'll just play a brief game, get myself killed real quick. So we'll still enter the initials. Now if you see, I can actually do hyperspace here. Hyperspace is the down arrow, which I'll do right now. And get myself killed real quick by flying through everything. Boom, game over. Now the arrow key is going to operate differently. So I'm going to enter my initials, Q, and then here's the down arrow, boom, boom, that ends it. So 3 times will actually exit out. So each initial, that's just like an enter key. So that functions differently, that key down. So going back to the player hyperspace, at that point, once a player is in hyperspace, at that point, once it's actually set, I look for the 0.5 to 2.5 seconds for that to elapse. And if that time has elapsed, which we're doing a comparison of now ticks versus the current or the when it started ticks, and at that point make sure that the player, if they were actually in hyperspace while they were traveling, reduce their velocity down to 0, set their position to a random position, XY coordinates, random position, making sure they've got a boundary for the edges. So Asteroids, the official game, never seemed to actually have the player appear anything but within a certain specific area. That's never too close to the edges of the screen or anything like that. So I avoid that by basically creating a box inside the screen, and at that point just reset that to hyperspace is off. So next one thing that we're checking for in the timer loop again is the player destroyed? Now all of this, just to show you real quickly, and we'll return to this in a little bit, the player screen. Player is the ship. So all of this is defined here in the ship class. So what I'm trying to do is just basically make it so where we have the ship, we've got the asteroids, we've got the projectiles that are fired, we've got the UFO, we've also got the scoreboard and the sounds. All of these are contained in objects that I could easily manipulate and do things with. So, that's, for me, it just seemed a little bit obvious to organize this. Now, as I got into this and I started getting into granular functionality, it became a little bit spaghetti, which will become obvious as we move on and everything. So with this, if the player is destroyed, at that point I iterate through all the asteroids, or if the player is not destroyed, mind you. Do a check. Does that player collide with an asteroid? Just make that determination. We've got a specific radius of the player that's actually going to be within this function call right there, and that will actually do a determination. Does the radius of the player intersect with the radius of this asteroid based on that position? Now I'm going to dive into here real quick. Go to definition, and you can see real quick I'm using Pythagorean theorem to determine that. So I'm just basically taking x minus 2 positions x minus 2 positions y, the asteroid and the player, and then I'm squaring both of those, and that at that point will actually be used to determine the collision. So we've got the radius that's actually of the ship itself, the object radius, and I was having problems with this because of sometimes the speed of things, where the collisions were missing. So I've got a little fudge factor built into that collision right there. And in the case that that object radius for some reason is less than 10, for some reason if it ever fell below 10 on the point that we're actually whatever's being calling into here. So if, for instance, an asteroid claims to have a radius that's less than 10 or something like that, it should never be in here. I was having problems with trying to trace down that problem in code one time. I just kept it in there. So going back, if the player collides with that, and if the player is not destroyed, which still shouldn't be destroyed at this point, then the player does collide. We're setting that to true. I think this is a little bit redundant, isn't it? Because if we're already in here, we don't really need to check, and that object does collide. Yeah, that's a redundant check, isn't it? Let's remove that, and then break out of that for loop. So, pretty sure that should function no problem. Okay, and if the player collided, at this point, we play the large asteroid sound. Now, the sound library, I've got a lot of detail on that, and I'll get into that one later. But and then from there, initialize the player destroyed sequence, which gets called in a lot of different cases. And all that does is just basically say the player is destroyed. Ships left, we decrement the counter on that. If the ships left is equal to 0, game over is equal to true, game over reset at ticks. This basically says we're going to initialize a counter if the player's in a high score screen. It's got a certain specific timeout counter that's going to be associated with it, and we'll be using that at a later time and everything. And then destroyed SF ticks, so we can actually know we've got a certain pause that occurs in between a player getting destroyed and a player popping back into the game, and this lets us determine that offset for that time to use at a later time. So going back to this, hold on, there we go. So that's what happens when a player hits an asteroid. Right here, player again isn't destroyed. The player is destroyed. So we fall into. I make sure that we can actually fall directly into this loop if the player is destroyed. That's why it's not an if else. So, meaning this right here can actually basically say, okay, we've got the player is destroyed based on a variable that's going to get set in this, or they may be destroyed from a prior iteration, from some other circumstance or something like that. In any case, want to make sure that they fall directly into this loop. So again, monitor the number of ticks that have occurred, and then we've got the resurrection delay. That's the delay I was talking about. And this right here, if you look at that, tells us how much time, which is 3 seconds, in between the player dying and the player being resurrected. And right now it's set as a constant value, which is going to be 3 seconds. Always set the player to center if they're being put back in the game and everything. If the player can return and we've got a problem with them actually coming back in, and there's an asteroid within vicinity or something like that, at that point I just basically say, okay, screw this attempting to place a player back in the center. That was the first iteration, so clearly this needs a little bit of work to make it so where we've got a certain radius around us that is free and clear as well. But this right here says, are we going to respawn directly in an asteroid? If so, well, forget about it. And at that point, we make sure that the player is no longer destroyed and that the player isn't moving anymore. So here's the forget about it portion of things, which is just using a go-to to skip over the for each loop and any looping mechanisms, because we just once we find out that we're appearing in an asteroid, there's just no use doing this anymore. So at this point, do a little check. Is a UFO active? So there can still be a UFO crossing the screen at this point. At any given point, there could be a UFO crossing the screen. So if the UFO is active and it's not destroyed, keep in mind, this is all basically the movement code that's occurring within this. If the UFO is active and the UFO is not destroyed, then we continue trying to play the loop for the sound, for whatever it is. It's going to be a spaceship large or a spaceship small. And I just do a little check and determination that the library itself is nothing more than a list of sounds, or it's a dictionary of sounds that references the sound as a file to play, and I'll get to that in a bit. The firing rate, I have a different firing rate for how quickly each of those UFOs can fire. So the smaller UFOs will fire on a more frequent basis than the large ones, and that's where this code is right there. So the 0.9 is, it's just basically, it's an indicator to say how quickly, and that's in seconds, by the way. So it's 0.9 seconds. So every 0.9 seconds, the UFO, the large UFO can fire. Every 0.0 or 0.7 seconds, the smaller UFO. So they fire on a much more frequent basis. So now I can demonstrate, well, screw it, I won't demonstrate. It's pretty obvious if you ask me. Now, this right here is the UFO firing tick. So this is where I check the firing rate. So are we actually in a position where this UFO can fire? So there's more or less two things that go on with UFO when it's on the screen. Number one, it moves. Number two, it tries to fire. And right here, we do a little check to see Big UFO has a lower degree of accuracy. So this was something I found interesting when I was watching the game, and something that used to frustrate the hell out of me when I was playing it in the arcade was that the larger UFO was considerably less accurate than the smaller one. So smaller one almost always seemed to nail me. So what I do is I emulate that functionality here by saying, okay, for the larger UFO, the probability of him hitting you is going to be 1 in 5. So that's basically a 20% chance that he's going to target right at you. And for the smaller UFO, there's a higher degree of accuracy. It's 20, and I've only set it to 25% because he was nailing my ass every time. But I could put that down to maybe 1 out of 3. That might be a little bit more appropriate because they definitely seem to be a little bit more vicious. So, and if so, if it's actually one of those, oh no, I think it is 1 out of 3. Yeah, that's right, because this is only returning 3 numbers. So this is a 25% and this is a 33%. So random function pisses me off. Had so much fun with it. That's sarcasm, by the way. So if our value that we get returned here is equal to that 1 in 5 chance or 1 in 4 chance, then at that point we more or less say, okay, this is. If it's not, then we say, okay, this is a random fire. And if you look at the random fire for that projectile, we can go take a look at it. All I'm doing is calculating a 360-degree radius. This is not in radians. I'm actually doing everything in degrees because that's how I think. I do the conversion to radians every time in order to be able to use the mathematical functions for Pythagorean theorem and that kind of stuff. But for the randomizer next, I calculate, hey, this is going to be a random direction fire for this UFO. It's going to be anywhere between 1 to 360 degrees around this UFO. So it's just basically going to be off in any completely random direction. And at this point, I do a little check to see is this time is used to limit the firing speed of one's projectile every 1/10 of a second. Yeah, so I've had code in there that had the random firing being fired so much, so this is basically a double check to make sure he just doesn't fire too much. And then at that point, I add a new projectile. There's a decay that's set on it, firing angle, the position, and the angular velocity. So the angular velocity is going to be, faster or slower based on any number. Well, what we're really looking at is the firing angle. That's the thing that's most important. The angular velocity is going to be constant. I don't even think I'm using that. Projectile. Oh, that's right. Yeah, that's code that I haven't gotten to yet. So that was actually in regards to the ship's movement, projectile movements in general, taking into account momentum information based on the position of the thing firing it. So that's one of the things on my to-do list. I don't take it into account at all. So that right there is the random fire for the UFO, and for the for the non-random, at this point, I do a quick Pythagorean theorem, a arctangent to 2 call to determine the angle from the UFO to the player. At that point, I adjust the angle. Well, this is to fix the problems with a tangent too, with what it returns. So I adjust the angle by a 90-degree offset to pinpoint the player, and at that point I do the not so random fire, which more or less does the same exact thing as the random fire, with one exception. I give it the angle of which to fire, so there's no random generation within that of that. So we know 1 out of 3 or 1 out of 4 is going to be aimed specifically at that player. The rest of them are not, and this is why. So and that functions just like the game. So that ends the UFO's operational portion of things. And then from there, I do a check to see if the player collides with the UFO. So before we did a check on the player collision with the asteroid. So collision checking is pretty much all I'm doing. That combined with sound playing within the timer loop. And with this, we just have the position and the radius, and again, initiate player destroyed sequence if it actually returns true. Trigger the collision sequence for the UFO, basically saying to the UFO, get off the screen. Also, the current sound for the UFO, we tell it to stop, if I'm not mistaken. Current sound, stop. There we go. So we tell it to stop the little UFO sound, and also to play the destroyed asteroid large sound. So that's the big collision sound again. And because the player ended up hitting it, he still gets credit for the score. So it's plus 1,000 for the small UFO and plus 200 for the big one. So player does not collide with that UFO. So we've got no collisions that are going on at this point. Now we're actually doing so before I did a check to see if the player position is teleported into that. Now we're actually doing the collision detection for the asteroid. And with this, I iterate through every single asteroid that's on the screen. There could be one small one, there could be 15 small and large ones intermixed, and medium ones, any number of different things that are being checked. So with this, it's just a simple call. Oh, this is just for the UFO. Again, for the UFO. Yeah, so, and this ought to show you what I was actually going through as I'm developing this thing. So, you can tell, like right here, I've got the players destroyed first, and I'm checking player collision stuff. Then later, I said, okay, well, it's time to implement the UFO. I hadn't gotten into the UFO. You can tell the order of my implementation and everything. So with this one, I inserted the UFO code here, and also inserted the UFO. Oh, okay, that's right. The UFO ends up colliding with the asteroids too, because I had the bug of where a UFO would quite literally pass through the asteroid without colliding it. And in the video game itself, the 1979 version, that doesn't happen. And if there is a collision, it will take out that asteroid, and it'll also split that asteroid in two. So that's what this does right here, is it does a check to see if the UFO is actually moving across the screen. Does it hit the asteroid? And if it does, then if it's not a small one, what it does is it actually splits it into two. And here's that code for that. So it just basically says, okay, we got a pseudo-random velocity that I'm going to determine based on this angle of impact and everything. And it's going to be at a new angle that's going to be based on plus or minus 25 degrees, based on the angle that it was already moving at. So I'm trying to have some kind of physics that are working in here. If an asteroid is hit by something, in a general sense, it's going to be deflected off into almost random directions, and that's what that's doing. It's just basically saying it's got momentum in this direction. when it hits that direction with that UFO, it'll fragment, and it'll fragment in two different directions, generally speaking, based on the direction that it was already traveling. Now, if I was really doing physics, clearly, I would have implemented this with a little bit less randomness, but because I'm not doing true physics, or I'm just basically doing two-dimensional physics, if I was doing three-dimensional physics, I would definitely implement this differently. I'd be a little bit more respectful of physics and physics movements and that kind of stuff. But with this, there's just no reason to. So, in any case, that does the check right here for each asteroid. Nay, does it collide with the UFO? If not, then just move on flat out. The UFO just keeps on chugging across the screen. So now, next random UFO encounter. At this point, I'm actually doing a check. If the UFO is lesson system UFO not active, players not active. Yeah. This right here is more or less saying, okay, we do all the UFO checking beforehand, and like I said, the order of me coming up with this, as I'm watching the screen, is the order in which I put things here. So this is really kind of like a reverse engineering project. It's not the way I would have implemented if I would have implemented it originally, but it's basically me observing how the game worked, and at this point taking that and putting it into code, and taking each object as I'm going along, saying, okay, here's the UFO functionality, here's what I need to do. And every time I'd get to a certain point, all of a sudden I'd say, okay, well, we need the UFO coming in to begin with. At first I actually had this spawn, so where it would spawn by me hitting the F1 key or something like that. Yeah, I think it was the F1 key. And then all of a sudden, that way I can check to make sure everything else is working. But once I ripped that code out, all of a sudden I needed a way for this to actually come back in, and the UFO to automatically come into place. And that's what this does. So at this point, I just do a check. Okay, we've got a certain interval for the UFO that the UFO can't come back in. And once that interval has actually elapsed, which is dynamically set through right here, the randomizer. So we've got 5 to 15 seconds for the next random UFO to come. And that changes based on the level. So if you flip up in level, it'll actually increase based on the level. So it'll start over, the timer will start over. So it's when you immediately get into a level for the first time, a UFO will not appear, and the same thing holds true for the arcade game too. So I was trying to actually preserve, this is exactly how things work there. I'm trying to translate that to C# code and everything too. So when a level progresses, you won't see a UFO for 10 to 30 seconds based on the level. I haven't been able to monitor too many levels and everything to know how accurate this is, but I think that there probably is a little bit of work that could be done on, saying, okay, at level 2, at level 3, at level 4, here's the likelihood that a new UFO is going to come. And they do tend to come quicker in higher levels too, so this certainly doesn't reflect that, but the code is there, so we can actually add in conditions, like this, to basically say, okay, at level 3, we can take this and basically say, okay, he's going to be coming at 10 to 20 seconds, but for every level after that, let's say 25 to make it a little bit more reasonable, and then for every level after that, he's going to come at 10 to 20 seconds, so he'll be appearing quicker, which reflects the actual code or the actual game itself. So with that, we determine when they can start firing, or this is the start firing tick. So what I do is I monitor the amount of time that occurs for them to fire, and they cannot fire a projectile until a certain amount of time is actually elapsed, and this is actually indicating the start time of when this actually appeared on the screen. So that way, when later I do the calculation, I can determine how long it's been since they fired last. And like I said, we've got the ambient accelerator. And why did I put this in here? tick since last start. So the only reason I put this in here, next random UFO, this is unrelated to next random UFO encounter, all that logic, but what it is relevant towards is the player being active and the UFO not being active. Big thing here that I was looking for was the player being active. The ambient accelerator is the accelerator for the interval for the sound that's going to be played. So if we can see the next background sound, this is the loop. So if I go and I hit F5 again, right away we'll hear boom, 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 boom. That's directly rated to this ambient accelerator. So I set that and I erode that so it becomes 0.8 seconds, and then it becomes 0.6 as the amount of time at this level progresses. So let's say you've been in here for 30 seconds playing this level. Well, it's going to reach a pretty frantic pace under 30 seconds, but then once you hit 30, it'll actually be at the fastest pace that it can possibly be. And this right here, this is where we spawn the UFO. Again, I don't know why I put this here. Not the appropriate place for it, but I'm just going to leave it in for right now. To do, does this really need to be here? It's outside UFO code later. It's because I don't want to break any functionality, and it's working pretty well right now. I'm just going to leave that in there for now. But this isn't the appropriate place for it. I'll just leave it there for now. So UFO, the spawn UFO actually happens when the next random UFO counter has elapsed and the player is still active and the UFO is not active. So the UFO is not on the screen. The next random UFO encounter, 5 to 15 seconds, has elapsed, and at this point we're actually saying, okay, well, spawn a UFO based on this current level and the amount of time that's progressed. And within that, what did I screw up? There we go. Within that, it'll actually do a quick, if I'm not mistaken, we can take a look at this, the level and the level time. And at this point, if we've got 45 seconds that have elapsed from this level, so not only do we have an ambient timer count for the music, but if 45 seconds has elapsed at this level, and we've got a little function, my observations of the game have resulted in lower levels having a much higher initial incidence of larger UFOs, and the longer time spent on a level, the higher the chance of a smaller and faster one. So as you play the game, the level increase, the chances that you're going to see a larger UFO is going to diminish as your level actually increases. Similarly, as you play a level, the chances of seeing a large UFO is going to go away and be replaced by using a smaller one. The smaller ones, like I said, are more deadly and more accurate. Well, that's what this does. This basically says, okay, we've got the level time that's in this, so, and then we take that times the level, and if that is less than 45, so at the first level, we're looking for a 1-for-1. It has 45 seconds actually gone by. Level 2, it's going to be 22.5. Level 3, it's going to be, and so on. So as the level rises, your chance of seeing your chance of seeing a larger one are going to diminish greatly, just like I just said. This right here determines, is that going to be going left or right for the position. This is all in the spawn UFO, which I'll take through the entire UFO class, and this covers how it gets spawned. Next possible directional change is going to be this right here controls the direction that it can change up, down, or so if it's moving left to right, you've got one of three possible directions that it can go. It can go up 45 degrees, down 45 degrees, or laterally and maintain a straight line. That's exactly how the video game itself, the arcade game, works. So this right here makes a determination how frequently that occurs. So it doesn't change direction that much when you're actually watching a video game. But because it changes just enough and it changes regularly and very randomly, at that point I'm actually doing a random check for that position. And just basically saying, okay, we're going to periodically change the direction, and at that point we'll change it based on that 45 one of those three angles that it could potentially change in. And if so, I just simply adjust the angle, that it's moving at and everything, and keep on chugging along and everything. So this spawns the UFO for the initial time and initializes the initial angles that it's going to be moving at. So with this, the next possible directional change, it will always be coming in a straight line, but it will always move at a positional angle after a certain amount of time that it's actually come on the screen, and this is where that amount of time actually is calculated for it to elapse. So next random UFO encounter at this point, we're saying, okay, let's say this UFO is destroyed immediately on coming out, and I set this just in case for some reason that trigger code doesn't work, which it should anyways. But I just make sure that we're not currently trying to spawn more than one UFO. And this basically says, okay, we've got a random 5 to 20 seconds that this is going to be going through until the next UFO can spawn, or potentially more. Now, let's say the UFO is actually already on the screen. Is it active? Is the player active? At that point, it just keeps on spinning and updating this counter, saying, okay, UFO's on the screen, so this will be the first time UFO gets spawned. For every other iteration, we're going to be seeing it hit this, so it'll keep on updating the counter. And let's make that 15. So that counter keeps on going. So that's it for the UFO code. So at that point, the last thing that we have is game over code, and why that's an else if statement. Let's go back there. Boom. Is playing. Oh, okay, that's why. So that's the main portion of the loop. When the game is when it's over, at that point we've gotten a message to basically say it's over, but we may not, everything else may be in an indeterminate state. So we can be in transition saying, okay, player got a high score, we've got a certain amount of time that elapses, even if they don't get a high score, that you see that game over message and everything. So this is the transitive state between the game has ended from the player's perspective. Do we enter a high score, or do we just simply display the game over message, or do we wait just that amount of time and then flip it back to the normal screen? So right here, I do that quick check. Is this a high score? And I hand them the score. Hand the scoreboard, the score, and say, hey, do we have a high score? If so, then we just put the high score screen up right there. That creates that screen. At that point, I actually get that. I set the score for this. So now that we've actually got that score, we say the new high score for this one is high score. This may not work the way I want it to. Yeah, well, because it'll function later. And we've also got a timeout that's associated for the high score screen. So the high score screen will go away after 30 seconds of displayed. and I think I've got that hard coded right now, ticks per second. Yeah, it's a constant. So timeout before display playing high score screen, and timeout for high score displayed play screen. So we've got a little timeout in between the end of the game and then the high score screen's displayed, and this right here calculates when to actually start displaying that high score. Here's the interim where there's literally nothing displayed. You see the game over, you don't see a high score screen, there's nothing going on yet and everything, but the player will have a high score. And then you got the conditions where they didn't get a high score. They didn't do jack shit. So at that point we say, got high score display? No. And at that point we're going to have later logic that'll actually fall into flipping the state altogether for the player to not be playing. So in this right here, MB display, make sure I'm still recording here, which we're looking good. Display enter high score screen. So this is saying we do have a high score that's being displayed here, and at this point we want to only display that if we're supposed to be displaying it. So it's in between the timeout when the player ends and the amount of time maximum that we're going to display the high score screen. So if it's greater than 30 seconds, I think that's 30 seconds. Well, let's do a little check real quick. Actually, let's go definition. Yeah, 30 seconds. So if it's 30 seconds, we at that point fall into this logic. Game over. Yes, game's over, which we shouldn't even be in here. Sometimes I've got redundant fucking code. Remove that. Player is active. So this is where I said that we're toggling the state of the player to make it so where they're no longer physically engaged in the game. There's no more nothing. So we've gotten everything has been turned off. We're making the determination, is it a high score? Cool, it is, but the game's over. So at this point we say player's not active. Enter high score to screen display. Yes, we want to play it. Is a high score screen done? Meaning, have they actually selected all the initials and everything? The answer is we don't know. If it is, then turn it off. We add that score to the list of high scores. We display the high score screen itself, which is the list. If you go back over here, it's that little list right there. So we've got 1, 3, 10, and my name for each one, 880. That is actually accomplished by this function right here. We set the high score entered score screen to null. So there's a check initially if it's null, and at that point this is where we know that the high score screen has not been initialized, and we have not checked whether or not this player has a high score or not. So I just wanted to make sure that this it's a boolean, it's a tri-state boolean, that it's either true, false, or uninitialized. And if it's uninitialized, that just basically says we haven't done a check yet. If it is initialized and we've got a true, well, of course we want to display it. If it's false, well, of course we don't want to display it. But if we've already done the check and we've done with processing altogether, and we're not going to fall back into this loop, at that point we're going to reset it back to null. So subsequent players that come and play this game can actually check to see if they've gotten their high score as well. No longer playing, no longer active, game over equals false again. How many times can I put redundant code in here? Wow. I do it a lot, don't I? Problem with copy pasting. So, if the cur ticks, what was cur ticks? Is less than 0, less than or equal to 0, we're not displaying the high score screen. I can't remember what this code was for. So cur text to display high score screen timeout. minus divided by less than equal. I actually can't tell you why I did this code. Let's go say add ticks. That's a mystery. Mystery code. Why is this here? I can't remember why I did it. I don't like ripping things out that I don't know why I did it. So, displaying active display. Yeah, I can't tell you why I did this code. It's the mystery code. Okay, final condition. Enter high score display screen, or it's equal to null. So we've got the enter high score screen is either null or false, meaning we've either not initialized it or or it's already been determined as being false. In any case, false, and we basically say player's not active anymore, player's not playing. This is the first time around, the first pass, until all those timer values actually get called and everything. So if I'm still confused why this would get called. Got that. Cur ticks is less than 0. So ticks to display that screen less than or equal to 0. That really bothers me. Okay. So that is all the highest score screen. So again, like the UFO code, I ended up doing this code after the UFO code, and you can tell I waited until the last minute to implement the sound stuff because the sound stuff came last. So again, this, for me, there's two different ways to develop. There's you've got a business plan, business requirements, and everything. You've got the requirements that you've developed for an idea or a concept and everything. You've committed it to a piece of paper, and you basically created a plan of some kind, and you operate from that document, and that document itself outlines all the different possibilities for it as you go along. Well, when you're paying attention to a video game and more or less reverse engineering it, you can use that screen as a template per se, for ideas and concepts, but the problem begins when there's details that you didn't notice the first time around. And the same thing can hold true. Code tends to become spaghetti when you start going through the testing process. Well, when you're reverse engineering thing through visually just looking at it, same thing holds true. I'm just going through and just basically saying, okay, implemented the UFO, cool, get that out, that's all working great. Next step, what do I have to do next? Okay, well, now I've got to do the scoreboard. Okay, go through the whole process of inserting the scoreboard and that kind of stuff. Now, if I would have planned this out, I probably could have done a little bit better of a job on the organization, but I just basically dove into it and started, focusing on the things that I wanted to create and how I wanted to organize things. And then at that point, later as I started implementing, I started realizing, oh, this is getting to be a spaghetti. So some things I absolutely refactored, and the sound stuff is a great example of that. So here's the sound stuff, and this here on the timer loop is when sounds get called. And in this case, it's there's only for a couple things that are going on here that are happening on a timer type loop. Everything else for the sounds is done at the time that it's actually occurring. So if I hit the space bar to fire, for instance, and I'll just show you an example of that. So you've got that background loop, and that's something you can see in that. But now I'm going to hit the space bar. and that's done. That sound's done at a different time. It's done at the point that projectile, that key's actually sensed, and there's the projectile starts getting spit out. So this right here contains all the code for that background loop sound. You got a high tone and a low tone. I know it's going to be low by that right there. I've got a boolean. Is it low? Well, cool. Switch it over and make it high. Is it high? Okay, cool. Switch it over and make it low. How long is it going to be in between those periods? That right there, combined with this right here, tell me this. So this right here I use to calculate the amount of time that's going to take in between those different ticks. This right here, the ambient accelerator is used to basically say, okay, we got ticks per second, which is a lot. It's like 1 million. And then you take that and you take it times the ambient accelerator, which takes a fractional portion of that, the more that you're into the game. And at that point, it says, okay, once you're doing that, once the game progresses, in both level and also the amount of time that you're spending on a single level, that number decreases, and as a result, the next tick for this switch from a high to a low tune for the background music is actually going to diminish. So that right there. The other thing too was thrust, because thrust can be pressed and continuously be pressed for any number of seconds or even minutes too. If you've only got one asteroid and you're looping over and over again, the thrust sound itself is a relatively simple sound. But if the player is playing, and doing it constantly, if I didn't have a way of making the determination that it's actually that the player is still doing this, I wouldn't know. It's not based on the keystroke, because the keystroke can actually, you press it once down for the up arrow, and you don't receive it until it's actually received 10, 15, 20 seconds later. Well, the sound for the thrust is going to be playing the entire time. So that's what this does, is it says, okay, is the thrust playing? Or is the thrust key down? Is the player currently thrusting? That right there is that variable. If they are, play the sound. If not, don't play it. So I'll show you how I'm doing the sounds in a little bit later. Okay, so moving on, we already showed you the load asteroids for this level. The key down, this intercepts all the keystrokes. So you got the 1 on the keyboard. This right there tells us we've started the game altogether, and it's all it does. Just say that the ship's left is equal to 3. The player is playing. That's all it does. The up arrow only gets activated if the player is active, and at that point we apply acceleration to the player. Player is thrusting. Set that to true too. So probably, if I was to refactor this, I could probably shift that down into there and ask the player, are you currently accelerating? So that would eliminate that variable. But there's a lot of things that could be fixed with this. Left and right keys. We're going to rotate based on the direction of the rotation. And if you go inside that code, all I'm doing is just basically retaining the key that's depressed and the key of the rotation that's actually occurring too. So keys, accelerate, yeah, so it's the rotation. B is rotating. So now if I look here, the rotate key in the draw method is just going to notate whether or not the player is rotating, the rotation speed. So I'll get to that later, but what we're doing, all I'm doing is just capturing whether or not the player is rotating or not. So going here to that, back, key down. Is the player in hyperspace? If not, or is the player active, then at this point we're going to capture the hyperspace entry. So like I said, we've got 5.5 to 2.5 seconds, and at that point they enter hyperspace. And again, high score screen, is the other time that the down key is used. So we have 2 different usages for that, depending on the state of the game that it's currently in. Spacebar, this is the fire key. if MB space is pressed, at that point we're going to fire the projectile and then play the sound for that projectile. So remember how I said, the same time that an event happens is when I'm playing that sound, just to make it sound better, make it sound synchronous and everything. So, and at that point the space is pressed. I can't remember what I'm using that variable for. Oh, that's just to avoid reentrance. So that way, let's say the player hits the space key and everything numerous times. We've got a certain amount of different times per second that the player can hit a projectile, and that's kind of like the artificial limiter right there. So I only retoggle that after a certain amount of times gone by, and we can see that retoggle. When the space goes up, that's on the key back up. And there should be a retoggle. Let's see real quick. I'm going to hit it really fast. Yeah, so we've got a limiter in there, but I've got a problem with that. So, needs limiter to retoggle this. Let's move this up here, because that one's actually pretty, it's not huge. Projectile limiter. So I've got something that basically says that you've got 4 frames per, or 4 that can go off, projectiles that can go off at any given time, and that's actually calculated in here. So if count is 4 and tick_fire is less than that, then at that point I'd allow them to do this. And you know what? I'll fix that right now. Bool b did fire is equal to false, and equal to true. Return b did fire, and then from there I can go back over to here. If only then, and only then. That should fix that. Okay, I'm hitting it really fast. Perfect. So that fixed that little problem, so I just removed that. Bug didn't even hit the bug. Let's make sure that. Okay, so key up. So on the key up, that's for every key up or a key down, you're going to have a key up that's going to be associated with it, just to make sure that the acceleration is turned off and that the sound playing it is turned off as well. And also turn off thrusting left and right. You got to tell the player to stop rotating. So the ship is gonna discontinue rotating. The escape key, application exit. There's nothing else done. It's immediate exit. So don't do it if you're playing the game. Key space is the space pressed. That's should have been the limiter and everything. I'm gonna keep that there, but it's pretty. Well, it's every time that you can't press it down and keep pressing it down. You have to press it and press it back up and everything. So this is actually going to keep that noted. So that's it for the keys. There's not a whole lot going on with the keys. So now here's the crux of it. The paint method, and the paint method itself is used for drawing everything on the screen. And there's a little bit more done in here. Like I said, I took a hacky approach and everything to it, But all of this is GDI based, so I'm not using any DirectX, no Unity, no nothing for all this. This is all .NET code leveraging GDI and some APIs in the instance of the sound and everything. So right here, I'm actually taking the graphics and using that as the basis for drawing things from there. So create the projectile list and a list of projectiles for the UFO. So we've got two separate lists that we're going to be considering here. And each of those lists is going to be doing something slightly different because the UFO can't, you want to avoid collision detection for the UFO's projectiles against itself, and the same thing holds true for projectiles that are fired by the player. The player can't destroy themselves with their own projectile, fortunately. So, I mean, theoretically it's possible, but you can't get moving that fast and everything in the game. So, with the asteroids, for each asteroid that's actually out there, if that asteroid hasn't been destroyed, do a little check here for the projectiles. Does that projectile, any projectile that's in that list, it could be from 0 to 4 max based on what I showed you earlier. It could be 0 to 4 max projectiles are actually within that list. And if that projectile itself, if there's a UFO there and the UFO isn't destroyed, we do a quick little check to see if that projectile hits that UFO, and if it does, play a UFO destruction sound right here. Stop the current sound that's being played for it, and at that point we increase the score. So this is what happens when I hit that UFO with one of my projectiles. So I fire, I hit the space key, boom. This is what happens right there. UFO's destroyed. True. Boom. My score goes up by 1,000 for the large ones, 200 for the for the large ones, 200 for the small ones. It's 1,000. So next, no UFO on the screen, or there is a UFO on the screen. Next, does this point collide? I could put a continue in this to speed this up too, which I will. Now, can it hit multiple objects? It can potentially hit multiple objects at the same time. So I'll keep it in there. So if this asteroid, so again we're iterating through asteroids here. Destroyed. Yeah. Why are we doing it for each UFO? I probably need to fix this logic. I've got a little bit too much in here. List. Yeah, I'm totally doing the collision detection on the UFO too much. To do, move this out of asteroid collision checking. I might be doing it just, actually I think that's why I'm doing it. If it hits multiple objects at the same time, I want to make sure that it doesn't destroy. Yeah, that's right. It's kind of a cop-out excuse. I think there's better ways to do that. So anyways, if that point does collide with this projectile, so this basically allows it so where a projectile can destroy both a UFO and a asteroid at the same time. So if it does, then I increase the score by the point value that's associated with that asteroid. I play the sound for that asteroid being destroyed, which is going to be if it's not small, it's going to be a large or a medium sound. So there's different sounds for each of the asteroids. So there's large, medium, and small. So it comes into this portion of things. It's not a small one, we know that, but it will be a large or a medium one. And at that point I play that sound. And then, because that projectile has fired and hit that asteroid, at that point I'll split that asteroid off into two different separate pieces and be on my merry way from there. After increasing player score, of course. So we're going to see the asteroid being destroyed. In the case that I've actually hit a small one, all we do is not credit them. Is that right? No, I credited them before. In that case, we just play the sound for the small asteroid being destroyed. And in any case, we had an asteroid that's destroyed, so we remove that projectile. And yeah, that's it. So next, that's the processing for the player's projectiles. After that, we do the UFO projectiles. So for my projectiles, the only collision detection that we're doing is for the UFO and for the asteroid itself right there. Those are the only two things it can actually collide with. Now the UFO is different. UFO, we do the same exact thing as a player. Does the projectile of that UFO collide with the player? If so, then we remove that projectile from the list so it completely disappears off the list, and then we initialize the player destruction sequence, and that way you're going to see the boom. So doesn't look like there's a sound associated with that though. I can fix that. Oh, is it here? Peak definition. There's no sound associated with it. Okay. If MB player destroyed, not. Yeah. And sounds dot large. So the player collided, player got hit, player's destroyed. Play the sound. I'm wondering if I play it elsewhere. Check on this. Yeah, I can check it out real quick. Sure enough. So now we're going to have that sound played properly. Okay, that'll fix that. And then, does the projectile of the UFO hit an asteroid? And we're going to have the same problem here with it not playing, aren't we? New one. Correct. So. And actually we want the same logic that we had up here. So that, and same thing for that else. My sounds, take that and put that here. So now, so at this point here, if the projectile, if the UFO's projectile hits it, not only will it destroy it, but it'll also make a sound when it destroys it too. So, finally, if the player collided, we save the current player position, I increase the score by the asteroid point value associated with that. So this is a case where the player is actually moving around and we've got a collision detection that's actually detected on the player hitting that asteroid. And you got the same problem here with the sound. I'm curious. Did I not check this one too? Clearly I had some work left to do on this. Yeah, we got sounds associated with that one. I don't know where that one was done at, but So got the move angle for the new asteroids. We saw that that worked and functioned correctly. So then, high score display screen isn't displayed. So we're going to have, yeah, so in the case that we're actually displaying the high score, we don't draw the background to allow the player to enter their initials and everything. And then for the animation for the radius, this is for the drawing code, keep in mind, when an asteroid or anything destroys, so I'll show you right here. Both the destruction radius and also the radius of the ship blowing up expand, and this is the asteroid's expansion radius as it explodes. So it explodes from the center and explodes in a radius of 2.25 basically pixels per second. And it's only a finite amount that it can actually go, and that's the max anim radius. So I think it's maybe 40 pixels altogether from the center, whether or not it's a small, medium, or large one. So it's all going to be the same. So animations all taken care of for destruction of that asteroid. Remove it. That's it. That asteroid's gone forever. So finally, to get into the player drawing code, it's relatively simple. Is the player active? Yes. Draw the player. Draw any projectiles that player is firing right now. Okay, cool. If the high scored screen is displayed, then UFO. If the high score screen is not displayed, mind you, again like that previous code up there for the asteroid, at this point we draw the UFO and any projectiles that it may be firing too. Now, any projectiles that are actually being, for some reason, fired at the same time that the UFO is not active, which shouldn't be a condition that shouldn't happen, at that point just don't draw them. Draw the UFO in any case. So UFO has drawing code, has other code that has to turn it off and everything too. And the final two pieces of the draw main scoreboard, which is the upper left score that the player currently has. It's also the top portion, the high score, and also the bottom, the copyright message by Atari. And then we've got the high score screen, and this is the only going to get executed if and only if the high score is being displayed. So that right there tells me that. If it's being displayed, then at that point draw. If not, it's just a in and out call. So got a couple other things that are left in this. We're almost near the end of the form. Initiate player destruction sequence. The player is destroyed. We toggle that on the player ship itself. We subtract the number of ships that are left, and if the ships that are left is equal to 0, we toggle the game over switch, and how much time till the player can start another game, which is going to be hard-coded 4 times ticks per second and everything. So that can probably be extracted and put into constant. And player destroyed SFX ticks is where that's the variable that I'm using to determine whether or not they can actually go into the high score screen and everything. So this is just the beginning of that. So we've got 2 seconds before the high score screen is displayed. This tells me that this is the beginning of those 2 seconds until that screen can be displayed. Now, the UFO exits the screen. Now, the UFO knows its position on the canvas and everything, the canvas being the screen itself. Now, when that UFO exits the screen, it turns off all its functions, and at that point it ceases to draw itself anymore, and it toggles a variable, and it has a callback into this function that basically says, okay, we are done, and we don't want you to continue playing the sound loop. So this actually turns off the UFO sound as it exits the screen altogether. And yes, this is double buffered, and that's the only way I can actually do the draw code on here. So with that said, I know this is taking a little bit long here. I'm going to quickly go through some of the other things that I've done with this in order to get that working. So that's the main portion of code and how this thing functions. Everything else is a support object on here. And I'm just going to start in alphabetical order. Now, if you can see, for references, I've got literally nothing, but the core references for this. So there's literally nothing else in this project, everything. No audio stuff, no nothing. And it compiles down to 1400 K. I think I can reduce that if I actually manage to find a better way to do the sounds and everything. But the first thing I have is the animations, and this is the where I intended to have or where animation dimension list. So what I've done is if I go in here into open folder, shit, you're not going to be able to say. Uh, Basically, I've got a circle that I've defined, and what I did was I took the asteroid from the original game, a copy of it, and I put it into a Corel Paint Shop or Photoshop. What was it? Corel Paint Shop Pro, and I mapped out the offset positions for everything from the explosions to the debris for an explosion to the asteroids themselves, based on a center point and then a unit vector of 0 to 1 from center on every single entity in the game. So for instance, this right here, we've got a initialize. Where am I using this one at? Animations. I'm not too sure if I'm even using this anymore. Am I? Yeah. Okay. Where's my call stack? There's my call stack. General. Okay. Okay. Oh, yeah. That's just the destruction animation. So for the destruction animation, it's just a simple series of points, and that series of points starts at 40 degrees, and then there's another one at and 0.85 from center. This allows me to expand this based on a radius of 5. This would be 0.85 times 5. This one here would be 0.75 times 5. So this is how the destruction animation works. So where you can have an immediate radius of 5, and then it can jump up to 10, and keep on incrementing from there. And you see those points grow based on this unit vector here. So at 10, it's going to be 7.5 pixels from the center point for this 75-degree point. And for each one of these, that's just how that animation works. And you can take a look at that animation, the destruction animation. Where's the destruction animation used? So for the draw code for the UFO right there, if the animation radius is less than the radius of that UFO, for the destruction, then it'll increment it by 2.25 and keep on growing that radius of the destruction animation sequence. And for each one of those, it'll actually plot an XY point based on the unit vector and the position, the angular position based from center, and continue that animation for the destruction. Now this is true for the asteroids, for the UFO, but it's not true. The only time this destruction animation doesn't hold true is for the player. So I ended up opting for a different way to do the player animation. I had the intention of putting all animations like that, the animation sequences, not realizing that there's only two, and that's the animation of the destruction sequence and the animation of the player getting destroyed. And I thought I'd be placing both of them in here, but I just opted not to, just because of it was just a little bit easier not to. So that's the destruction animation sequence. That's simplicity in itself. And then the asteroid, I do a very similar thing with this. You've got the couple things that are true, they're going to be true with every asteroid that's out there. You got a maximum radius, and this is in pixels. Um, you've got a number of points that's associated with each one. So there's a fixed number of points that's associated with one. And then you've got maximum velocities, speeds that can be associated with each one too. Now, each one has a slow speed. They cannot go any slower than 4 pixels per second. So, but for the smaller the asteroid is, the faster that it can be on the screen and everything. So that's where I carry these constant variables and everything. And you got the enum that actually carries, is this a small, medium, or large asteroid? And then if you go down here, rather than step you through those variables, every class that actually has dependency on drawing, in a lot of cases, will draw itself on the canvas, and the canvas itself is being the asteroid's form. But this right here is initialized with an asteroid size and its position, its XY position on the screen. And this asteroid, every asteroid maintains its position and also maintains its velocity. So with that, here's the asteroid size. Has this asteroid, the dimensions been initialized? And this is a static variable, if I'm not mistaken, asteroid dimensions, just to make sure that I initialize it only once. Asteroid dimensions. Where the hell is it? Go to definition. Yeah. So the asteroid itself, later, I actually define a static list of the asteroid dimensions. So I initialize it once and only once for the entire application. And this is basically every asteroid, if you take a look at it, I'll bring it up real quick, you can see has 1 to 4 different configurations. So if you see upper left and lower or upper right now, same exact, no they're not, they're slightly different. The left 2 big asteroids are the same size. So there's 4 different configurations, point configurations for every single asteroid. And whether or not it's the small, medium, or large, they're the same point configurations that are only scaled differently based on their size. So the big asteroid, yeah, I said big asteroid, but that's just asteroid number 1, asteroid number 2, asteroid number 3. I thought it was going to be different based on the big and small ones, but it ended up not being that, which was really kind of cool. So you got a list of points here that's associated with a big asteroid, with one of them. And you've only got 3 configurations. I was lying. I thought it was 4. So, and what I did was I just basically did the same thing. I plotted the points. So at 5 degrees, you've got a point that from a radius center of, let's say it's 500 comma 500 XY axis, extend out 0.4 from the center direction. And if the asteroid itself is 28, then at that point we expand out to 0.4 times that. Snack time. So, and that's what that tells me is, so this one here for the large asteroid of 55, if we take that times this 0.4, we're going to end up with, what is it, about 20. And so offset from the center. So we know that that's going to be an interior line. This one's going to be all the way on the outside. So it's going to be extending to the radius of that asteroid at 68 degrees. So 89 degrees, 113, 160, 208, all the way around to 333. And then a final point is actually drawn back to the first point in that. So I maintain that in an asteroid's dimension, a list of vectors. So basically there's 3 vectors that are placed into it, or 3 lists of vectors, and each list of vectors, 3 vectors in all, or 3 lists of vectors in all, contains all the different points on the asteroid. So, anyways, hold on a second. Go on. Pause for 1 second. So anyways, coming back here, we've got asteroids. So here's where the asteroids actually formed itself, and then we go to the size and the speed. So we've got the different speeds that are actually set based on the size of the asteroid. That's all done right here, and then the position is equivalent to, it's a random. We've got a random position that's actually set for each one. Now that can be changed later, but and if I'm not mistaken, yeah, I've got a point that can be initialized right there as well. And then I generate that the size based on the size for that. I initialize its velocity to be random, and then from there the angle is all going to be random as well. So any asteroid that comes in is initialized based on its speed, um, position, and also at that point the velocity and the angle are all dynamic. And that's from there. All it does is it draws each one. So the draw function that's called in the paint within the form asteroid, that's actually called, and that calls into here. And if the asteroid is not destroyed, then all I do is I iterate through all the points from and to. If the point is the last one, then I loop back over to the last one, and I just simply do nothing but draw lines. That's all it is a line from and to, an existing position and everything on the canvas, and it's all those asteroids. Everything is based on a series of lines. Now, the only time that I'm doing something different, is when the asteroid is destroyed. So in the case that it is destroyed, at this point I draw using a brush, a rectangle, if I'm not mistaken, a fill rectangle, and I'm expanding that series of points based on the destruction animation radius and a series of points that are actually obtained from that. I'm looping through that vector and everything, and I'm expanding that out based on the expansion that we're currently at and everything, if I'm not mistaken. In X, destruction animation radius, vector X. Yeah, so the vector X should be the offset position, and then the ND is the diameter. X position, collision location, X, Y, and then, yeah, and then it's just drawing a simple point. So as that thing grows in size, the radius itself will actually expand with that position too. So make sure of this. So we should see when I fire and hit an asteroid, boom, yeah, it expands. So that's where that's done, right there. Movement positions, same thing. We take the velocity, and we just do a check on the velocity combined with the angle that it's supposed to be moving at, and then at that point we calculate a new position XY for that. So the move is done simultaneously inside the drawing, the paint code, and at that point that paint code is actually used to calculate that position. So then if it moves off the screen, which we determine by the canvas width and canvas height, or it being less than 0, which means it's gone off to the left or upper portion, and then at that point we loop over to the other side. So we always know that if the position has been calculated to exceed those, then we always know to just simply put it over on the other side. And you can see that pretty easily by taking a look at the bottom one that just went from the top, or the one on the right is going to go over to the left. So that's where that code actually makes that determination. The generate takes an asteroid size, it gets the radius, determines the type of asteroid. So it's a dynamically chosen one of the three that could potentially be in there. If there's more, then it can certainly put that in there too. And then from there, at that point, just basically calculate the positional offsets for it, and then add those points to this vector and everything, so we know where this thing is and what the point offset is for each one, so we don't have to calculate it every time. Does the point collide? Which do a simple little check, and using Pythagorean theorem here, check value, and just say, hey, is this radius? And for this one, I'm doing a little fudge factor again, +2. So this basically takes anything and says, okay, if it's a 55 pixel radius, we're going to add 2 pixels to it just to make sure that whatever hits it does actually hit it. And that may mean some things that don't look like it's physically contacted actually are. So, but if that check val just checks out, and we've got the position that we're checking falls within a certain line within this radius and everything, at that point we've got a collision. So, pseudo random velocity. So at this point, I can't remember what I did with this. This is one of the first things I did. A velocity +5, fast speed. What the hell I'm doing here, I'm not too sure. I can't remember. New pseudo random velocity. I don't think it's being used, is it? 4 references, it says. Where? New one. Huh, okay. A velocity +5. Again, that's a mystery. Sometimes I get these mysteries. I've been working on this project for about off and on for about 2 months. This first game that I've actually coded all the way through and everything. So check into why the +5. I like putting my to-do notes in here to just question myself. Why am I doing what I'm doing? So I think it may be messing with velocity. I've had a problem with some of these things. If you take a look, for instance, see how fast those are moving, those little small ones? I've had a problem with those trying to actually diminish the speed, and that might be the problem right there. This might be the problem with small asteroids moving too fast. So anyways, that's the extent of the asteroid code. Next, I'll jump into the high scores. This is all going to be pretty quick from here. The other one, resource file. Resources that I've gotten here. Go in here first. We got 6 different resources. Now this is the only dependency that I have in this game, and these were sounds grabbed, sampled, processed through Audacity from the original. Now I tried going down a route of mathematically approximating and creating these things, and I did with a couple sounds. The thrust, for instance, the background loop sound, all of those are actually generated dynamically, but I got to the point where I just wanted to get this project out and everything, since it's free and I'm giving it away and everything. So what I did was I just captured the WAV files from the original game itself, and in honoring Atari, I maintain their copyright on the screen and everything, although the code that I'm giving away is free. And at this point, I just ended up taking the original WAV files and throwing them in here, and that's literally the only resources that are contained in here. So if you look at all the other resources, you'll see there's no strings, there's no images, there's no icons, there's no files, there's no there's no nada in here altogether. So with that said, that is literally the only resources that I actually have access to is those WAV files. So moving past that, going to the high scores, we can have maximum number of high scores that are on the list at the same time as 10. High scores are contained in the text-based file highscores.dat. And if you take a look at that file, it's a real simple list. So I won't show it to you. I'll just show you how it reads it in. So we've got a score here and an initials with each one. The initials is limited to 3, and for each one we're going to write all the lines from an array, directly from an array, using basically a ASCII text encoding and everything, and taking that score and putting it in there with it. So each score is going to be limited as well, but the thing that we're limited at is only three initials, and there always be three initials and only three initials. So that save will actually take that list and dump it to that highscores.dat file. The list is how we retrieve those high scores and display it on the screen. The load pulls it in, does a check to see if that file exists first. If it tries to load it in, if it's not there, then we just simply don't worry about it. The file write all lines will create it the next time it comes through, and then from there, if we try to go through all the different high scores, and if let's say there's only one or two, at that point, if the index is greater than that, and if for some reason somebody put in 15 or something like that, it automatically breaks out. So lines can length, can equal 15, it could equal 30. It doesn't make a shit of difference. We're just going to take the first 10 and break out at that point. And then it saves that high score in the list and everything. So if you've dinked with the file and everything, and you don't have 10 scores in there, that will screw things up, But just enough so where you may not see the scores that are truly the highest scores and everything. So other than that, the is high score function is called when a player ends the game, and that just does a check to see does any score in this list, because it is retained in a non-ordered fashion, does any score in this list actually is it a high score? Now, if there is no scores in this list, automatically it is a high score. But if all the scores, there is a high score that, or there is a score that it's higher than, we know at this point that it's a high score, and it just returns true. Add score adds a score to that list. It inserts it at that position and everything. I tried to do it ordered, but this is where I tried to, and all of a sudden I started realizing that's not working. And at that point, list of high scores. You know what I need to do? I need to do this by order, because this is actually going to have a problem with it. To do this list. So here's the problem. Let's say you've got 11 score or 10 scores, and this new one actually is higher. But because it's an unordered list, you can actually have the highest score being the last on the list. And what this will do, no, it'll just simply add it. No, that's fine. If not, it inserts it there and then replaces it. Yeah, that's right. Okay, this managed it. I'm fine. Yeah, I was worried that it might remove it from the last of the list. No, all it does is just a simple replace. So it inserts it at that position and removes the one that it's higher than. And then it saves and reloads them just to make sure that it's always there. And gets high score simply returns the highest score ordered by descending. Use a link. I love link. And then the highest score class itself, which is just nothing more than just a prototype structure. It contains the score and the initials. And then here's the enter high score screen itself, and I already have finished this. We're good there. Is done is triggered by the amount of characters, the initials that are being put in, and it starts off displaying on the screen a underscore underscore. So on the draw method, only if the high scored screen is supposed to be displayed, I will draw, push hyperspace when letter is correct, the high score screen. So all this stuff takes the Asteroids font handler class, which I'll return back to and show you that. I forgot to show you that. And that maintains a font size, a font position, the text that's actually carried with it, and it draws that as well. So that's just the vector graphics, A, B, C, D, E, F, G scores and all that kind of stuff. So the AFH class, Asteroid Font Handler, actually handles all that. text position, and all this does right here is just draw that screen. So this is where you enter your initials and everything. And this actually has its own key handler, since the form itself is not handling the main processing of the keys for this. It delegates to this, and this right here is where it'll actually enter the initials, make determination whether or not there's too many initials, and also indicate that it's all done and everything. So you've got allowed characters, and if you want to put more characters in there later, this is where you might do something like that. So all this does is just basically say, while it's not done, meaning we've got you know two characters, only one character that's been entered by this person or everything. Then at that point, we're going to allow them to use the left key to scroll down through numbers, and as you can see, it just iterates through, and if it's at the very end of that list right there, the all characters list, it'll go back to the end. So it just loops back around and everything. That's what this does. And then it just basically says, okay, here's the current character that we're displaying. And then we've processed this key. In the case of the current key being down, meaning I've pressed the down, meaning I'm advancing to the next key. In this case right here, this moves forward. And the right does exactly the same thing as the left one, only it actually moves forward. So this goes from A, you press right, goes to B, C, and so on in this list right here. So, the Asteroids font handler. At first I was using a font, an Asteroids font fold from a common site and everything, but I realized it came with a license with it. And I'm just like, you know what? Let's go ahead and focus on the on doing this without dependencies of any kind and everything. So at that point I ended up extracting out from the original itself, I recreated using arduous points, and each one I calculated based on its location, recreated each vector font letter B, C, D, E, F, and so on, all the way to the end. And this is, in a literal sense, drawing the points of the vector font that's actually in Asteroid. So I'm going to play it once again. And if you look at this game over screen, so push start, the PUSHSTART is a series of lines that are created in high scores and Q, all that. If you take a look at the Q, as a good for instance, QRS right here, I draw the positional offset based on where the current text is, and from the top and everything too. And each and every one of these I do the same thing with. This was an arduous process, and it's a lot easier to carry a font with something, but it was also kind of a neat exercise because I got to see how you can put a font into code and literally not carry any baggage from a font, from what comes embedded in binary within a font that you don't know of. All of this I can actually contain, within this, and make it a heck of a lot easier to not have to worry about licenses and causing offense to anybody for any other weird reason. So that's what this class does, Asteroid Font Handler. It literally maintains the Asteroid font and anything that's relative to it. So calculate offsets and store in secondary point, that's private. The key here is the draw code though. So this draws the lines for each character that's actually in the array of the text that's currently being rendered. And the text is actually contained up here. So if you take a look at the high scores, go back up to here, I assign the font size equal to 32. That scales the font. The kerning, which is the space in between each letter, I could dynamically adjust. The text here, push hyperspace when letter is correct. That's all maintained and iterated through right here. So we got the CA length. I turn that into a character array, and for each character I'll draw that series of lines. I go to each point and then I clear any other points that are not being done correctly, and then if I've got a period, I also have period. The period itself is the only thing that actually gets drawn a little bit differently, and I have to do that through a fill rectangle to draw that point. So a period or a point. You, you go. Okay. I'll only be about 50.
Jobs went out of the room. I don't know where she went. Maybe outside.
She's right there.
Oh.
Good night, Dad. Love you.
Treats. There's a couple right here. Okay. I seen that girl.
Okay, sorry about that interruption. Blah, 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 blah. Mom and Dad hitting the sack. So, like I said, I bit off a little bit more than I expected on this one. But it worked out pretty well. It's helping me get to understand, everything from fonts and, how to actually take care of them in code. And I can actually use this as a template later. This Asteroid font handler. I can use this as a template to create other fonts and, really output them pretty easily. I mean, that's the cool thing. If you take a look at the high scores and you take a look at how this is prepared, boom, I can actually, assign things and set them up pretty quickly. And the translation to me, putting this in in a three-dimensional environment is really where it's going to become cool, because my goal is to start getting versed in three-dimensional code, particularly focused on VR type stuff and everything. And this will help me and also make it so where I don't carry any external baggage in the way of fonts or any kind of libraries or anything like that for doing my text and everything. So, anyways, with that said, high scores done. Asteroid font handler. Sorry, I'm zipping through this. Next program. That's just the normal stuff that gets fired. Projectile. Not a lot of code associated with this, but very quickly, you got the projectiles, which gets the class, the constructor right here, tells we keep a last tick of when the last one was fired, which is going to come in handy because I'm only allowing a certain angle, I'm sorry, not angle, rate of fire, and that last tick is crucial to actually keep at all times. So the draw code, if and only if there's actually projectiles that are in this list, then at this point I'm going to iterate through each one, determine its angular offset positions and everything, and at this point this is where I actually tried to get into taking into account the momentum of the ship and everything, and I'm doing a really piss poor job because I failed physics 3 times back in college, university. So with that, I ended up going down the path of trying to actually calculate taking into account ship momentum with the positional offset of this, so I can actually calculate the how fast this projectile is going combined with the velocity of the ship itself. But I didn't quite work out that way. In any case, what I did do was I did accurately portray the positional offset of what how fast this was going, and I get the sine of the angle and the cosine of the angle that it's actually firing, and then I calculate that times the speed, the projectile speed, the velocity of how fast it can get fired, and I, at that point, displace its position by the x and y coordinate values based on that. So that from there, I calculate a new position based on the point that and I also wrap around too. So here's the wraparound code. If position of x is less than 0, then we know that it went off the screen being fired from the right to the left, and at that point to wrap it around to the other side. So we're going to take the canvas width minus plus the position x, which is going to be a negative, and at that point we're going to have canvas width basically minus an absolute value of x, and that's going to put us in off to the right hand side, and based on the y position. Same thing happens for everything else. So all this code here does is calculate the wraparound for the projectiles. So this right here gets a position, and that's a fixed position. So some things can go off screen. This wraps it around. And then at that point we draw it, and it's a point, but it's a little bit bigger than the point of the font. It's a 2 by 2 pixel basically that we're filling a rectangle in with the current brush, which is always white in this case, and we place the position for this projectile based on that calculation above, and any wraparound stuff that we're doing. It is going to have the angle that it's moving in, and it will retain that angle too. So its angle is a fixed angle. So we know if we wrap it around from the left to the right, it will still keep on going to the left until it actually has a decay. And that decay is started here, and it's incremented here as well. So we've got the amount of ticks that have occurred since it happened, plus the amount of ticks that from the last tick, and then we actually do determination. Where's the decay check? Oh, the decay check's on the outside, I'm pretty sure. So if I go in here and check for decay, no. Form asteroid, where is that used? Oh, there it is, decay time. Um, so once I've incremented that decay, keep on, we iterate through that list again, and then make the determination, has the decay time for this projectile been exceeded? And we've got a decay time that's set for each one. So from the point of fire, it has 1.2 seconds from the point it'll actually decay, and we'll no longer see it on the screen. And this is again just visually saying, hey, does this looks about right? And god damn, a fucking mosquito in here. Hate mosquitoes. And yeah, so we've got the fire. We already saw this one before, talked about this. There's only 4 projectiles that could be fired at the same time. Going back to the decay thing, once it's decayed, we remove it from the list, and at this point we've got one less in that list that's contained. So if there was 4 projectiles, now it's down to 3. So the fire, that's something, like I said, we talked about before. Player, the position, the point that the player's at, or the position that they're firing from, the angle that they're firing from, and the angular velocity, which, like I said, is something I haven't been taking into account yet, and it's something I've got to work on. So it's past my physics level. And the random fire and the not so random fire. These are 2 classes that are added specifically for the UFOs, or 2 functions that are added specifically for the UFOs function. So the UFO says, okay, we're going to randomly fire, boom, and at that point it actually has an iterative list. The player never uses this functionality. Not so random fire calculates an angle, and or it provides an angle from the UFO, and this one is a completely random fire. And then the projectile itself. You got decay time, the speed in pixels per second, the current decay, the firing angle, the angular velocity, like I said, used to for offset for speed, the current position of that projectile, the ship velocity, which I was going to carry with it so I can actually help calculate the angular velocity. I still didn't get an idea, and the angle of ship momentum. So you can actually have a ship that, I'll show you what I hadn't implemented yet. Right now, that ship is moving, at an angle that's not with the angle that it was pointed at. So the angle of ship momentum at that point was literally 90 degrees off from the angle of which it was pointed at. So I wanted to have that taken into account, but I'm also going to have to, I had to figure it out with thrust and everything too. So, quickly moving on, scoreboard. This is more or less the same thing as the highest score screen, only it's the scoreboard. So we got the copyright message, which is down at the bottom. I'll hit this again and show you. Copyright message down there at the bottom. Push start, high scores, all this. The push start, game over message, player one message. If you wanted to make this multiplayer, you change that. And rewinding a little bit. Score starts off at 0. High score starts off if it doesn't have a read on a file. This is what I was defaulting it to before I actually started saving the scores. So a million. Ships left is equal to 0, so the scoreboard carries with it the current state of the score and anything associated with it. Number of ships left, and score. Anything that's related to that stuff. Not a whole lot right now. Not a whole lot actually altogether. So ships left. At that point, we've got the amount of ships that are actually going to be there, and this this is actually what paints the ships, the number of ships left for the up on the scoreboard. So I'm going to hit F5 again. I've got to work on that whole why does it draw off to the left hand side first thing. That's kind of annoying. I just started doing that. So if I hit 1, I've got 3 ships. If you look at the right below the 0, 0, you got 3 ships that are immediately drawn up there. This is where this gets drawn. It says, okay, we've got ships left count. Cool. These ships that we're creating here don't have collision information. All we want to do is just display them visually. Here's their position. Draw it. And at this point, it actually will call this down below in the draw code. So we know that when we remove one of these, it'll draw one less. So that off of that list. So playing is a player playing is the blink for the game over, off or on, the player one. So if you look, got the push start up above. That toggles the blinking on that. And delay between score display. So I timed it with a stopwatch. So this is just basically the cycle between the high score screen being displayed, the list of 1 through 10 high scores, and the normal gameplay itself. And it's 16 seconds. And high scores, and like I said, I took a freaking stopwatch to measure some of these things. So how detailed I got. Now display high score screen. This right here is the toggle for it. So this right here takes that into account, and this is whether or not it will display it or not. What else? The draw code. Now again, this is all it's doing is taking the Asteroids font handler, rendering this stuff. So we've got the toString, the player 2. D2, toString. Oh, duh. Okay, it's taking a score and it's converting that to that format, and for that text. So it's keeping the score a minimum of two decimals, or two numbers, two numeric values. So it can't ever go just show 1 0. If I didn't have the toString format in there, at that point it'd reduce it down to 1 0, which isn't like the real game itself. Text position, all that stuff. We're showing the high score here. We're showing the score. Why do I have that twice? Move that. That ain't necessary. Like I said, I just finished this up yesterday, so I haven't had the chance to actually go through and do this. This is part of the reason for doing this little code review. The blinking. Now it's the interval for the blinking. I manually just looked at that and compared it. Did that little fucker bite me? And then, yeah, so that's just the toggling for the blink. So that's a period, so it's a little bit less than half a second. is how quickly that blinking occurs. So this is the whole push start. Boom, 2, 1. So it's basically it's a full second for every cycle around, or just a little bit less than a second. And play the start message. If it is playing, maintain the score. High score screen is visible, which we always see. The next toggle, we're not going to, or it's not playing, so we're going to be toggling at that point. Now, if the high score screen is visible, we display the high scores, create the list, and this is an ordered list of all the high scores in descending order, so it just displays the top 10, and then draws them. That's it. Now, if the player is playing, we'll show how many screens are up there, or how many ships are left, and we already got the score before, and it will always display the player's last score on the screen. So that's why there's not a check on this up here. So the scoreboard left will always contain the last player's score, which is why that isn't in here, where the ships left that are there. So this just basically shows how many ships are still up there. Is the game over? And is the high score screen displayed? If so, display the game over message for a finite period of time, and that's it. Once that's done, at that point it gets toggled. Copyright message. This is the message down at the very bottom. And that's it. So, the ship. Now, we've got a couple things that are actually important with this. The acceleration speed and the deceleration speed. This is all eyeballed. And the max velocity. So these are all calculated values based on how fast that this can move on a per tick basis, or per timer tick basis. So this isn't per second. This is on a per timer tick basis. So if you actually want to convert this to, per second, well, you've got 30 divided by 1,000, or 1,000 divided by 30, and then times that is the approximate amount that you can move on a per second basis and everything. So, anyways, these are just constants that are maintaining that rotation speed. There's a fixed rotation speed, and it can't go any faster or slower than that. That's where this is maintained. And that's why the radius problem was going on. Oh, funny. Crack up. That's funny. So I was having a problem with the collision not happening. Well, that's exactly why. Let's just put that at 10 to check this. Besides that, just variables. I mean, there's no use just explaining every variable except for the constants. Those are the important parts, because some of these are meant for determining, they're hackish in a lot of ways. You carry the position with the ship. That's important. Is the player active? Because the ship is the player. It's kind of the same thing. And it is the player in hyperspace. But there's other things here that are just used for timing and that kind of stuff. Timing was a bitch in this game. That was the biggest problem with all of it. And is the player destroyed? At that point we actually start the destruction animation sequence countdown and everything. So, just getting into it, the ship resets to center every time that we create a new one. Now we're going to reuse that ship quite often, so it's only instantiated once at the very beginning of the game, and then it's reset to center once a player gets destroyed. Now, on the draw function, there's a couple different things that happen with the draw. Is it in hyperspace? We don't draw. There's literally nothing going on. Is the player rotating? If so, then we determine the acceleration angle, and at this point, this is where I'm equals less than 0. Yeah, duh, I wasn't even thinking talking straight. Um, you start off at let's say 260 degrees, and you key left. Well, the acceleration angle, the direction that you go, the rotation angle, I should say. This was throwing me off, that terminology. The rotation angle is going to change from 260 to 260 minus the rotation speed. So it'll be whatever rotation speed was for the constant, which was 2.8 above or something like that. So it changes to 257 point, point what 2. So that's what this does. Is it just basically says in what direction did we rotate and how much did we rotate. So then at this point, player at this is actually when we do the drawing for the player. So if the player is not destroyed and if the player is destroyed, that's when we're playing the destruction animation. So the offset itself is the amount. So if you can take a look real quick, I'll show you. When the player gets destroyed, the animation sequence, like I'd said before, is considerably different. So when I hit something, watch the animation for the ship. Boom. It's all those little vectors, those little lines that go off in separate directions. So it's not the same as the asteroid. This draws those lines, which are actually fixed points, and expands them in a radius from the center. And that's what this does. It just merely calculates the amount of that expansion and based on the time, and at that point it keeps on expanding those lines to the point that they actually finally end up separately falling off the display. And I timed it exactly like the original game. So where some lines fade and dither or fade away faster than the others. So that's what this does. Is it says, okay, for this first line, after the 26th iteration, it no longer appears. It fades out. Now for this line here, after 30 times, this one it stays around a little bit longer. So we go for 38 on this one. So this one here fades away real quickly. This one takes a while. So that's what this does. It basically draws the line based on the current position and the offset from the center. So it just keeps on going out from the center like this. And it'll keep on doing that for that amount of time, and at that point it falls off. And that time's kind of like a relative thing that is kind of meaningless in a time sense, but in a counter sense it makes a lot more sense. So let's say on the first 12 ticks of coming through and drawing this, well, you're going to see this animation going for this one here. On the 13th you won't see it. So that's all this does, is calculate those positions and the offsets for each one. And why am I doing that SACA with each one? Oh, because each one's potentially different. That's right. Yeah, because the angle each one goes at is going to be different for each one, for a lot of them. So for these it isn't. For that one it is. This one. And SACA. Where's the initial SACA? Yeah, there isn't any. 0 for those. So each one moves off in a different direction. So one can go pi over 6 direction. The other one can go, angular change in all kinds of different directions. So what I'm doing is I'm actually using that was such a pain in the ass. Reminiscing there. Too much fun. So just to explain once again. Boom. Yep. let's do it somewhere more in center where we can actually see how it goes off in each different direction for those lines. That's everything that this is calculating. So the sine of the angle, cosine, combined with a plus or minus based on the direction that it's going in. So for this one, right, for these up here. Now, same thing holds true for these, but this is a little bit less sporadic, because this is the ship itself. So the ship, in this case right here, is destroyed. In this case down here, the else condition, it isn't destroyed. So I'm basically drawing the lines for the fixed position of the ship and everything. There's only 5 lines in total that it has. So it's 1, 2, yeah, so it's got 2 on the side, 2 that go to the middle, towards the middle, and then there's 1 for the bottom of it. So there's 5 lines altogether. This draws those 5 lines. And then if it's accelerating, then we also draw the jet flume, which is just nothing more than a single two lines that actually come out the ass end of it. Now the do physics, if I'm not mistaken, yeah, it's calculating the acceleration and velocity. So at this point, there's a little bit of math going on here that calculates the based on whether or not the player is accelerating, the increase in velocity, or the decrease. So in this case right here, player is no longer accelerating. It doesn't stop right away. This actually makes it so where they decelerate until it gets to the point of being less than 0. In this case, 0 or less than 0. So if that deceleration speed, for instance, falls down to negative 0.01, I don't want it to start going backwards, so I just set this to 0. And that was happening because of floating point issues and that kind of stuff. So velocity is 0, and if it is 0, and at this point we know that the player is accelerating, we increase the velocity by the acceleration speed. And if the velocity is not equal to 0, so they're not at a halt, then at this point I actually increase the velocity, but I don't set the angle. Constant increase velocity, same direction. Yeah, so each one of these tells, calculate new acceleration, no change in trajectory. Step 2, calculate acceleration changes. Positive acceleration, increase velocity from full stop. So this one here is not a full stop. The player's actually in motion, and at that point we increase the velocity accordingly. Now this one here, increase velocity mid-flight, could include trajectory change. This one was kind of a pain in the ass. So basically it's me pressing on the acceleration in one direction and then rotating. So that's what this does. Velocity, cosine of my angle. So at this point I determine the movement to change in that specific direction. Make sure the acceleration adjustment does not exceed maximum acceleration. So when you move, make sure that that new movement isn't in that new direction isn't going faster than the fastest velocity you can go. Now, calculate new angles. I was using ATAN at first, which was causing glitchiness, and that's just because of the whole positive and negative problems with associated with ATAN. So this little article I found helped me out immensely, and that's why I started using ATAN too to calculate angles. And there was a video from this dude here that helped me out a lot too. So from there, the positional offset's based on the new angle and locations and everything. So position, times current velocity, all that kind of junk. And you saw the does object collide. So the other things that we have in here are the acceleration, the rotation, and that's it for the ship. So the ship rotation right there, the key to press that we're actually, so is it rotating? If so, cool, maintain that state on. So as long as it's rotating, if it gets called into the draw code, it will actually rotate additionally for each subsequent entry into the draw. So that way it's very responsive, so there's no delay whatsoever on the UI. I'm going to skip over sounds for now and go to UFO. And UFO is kind of more of the same. I copied the ship code almost verbatim, and there isn't really anything different between the ship code versus the UFO code, other than a little bit of AI here. And this AI is contained within a couple things here. So we've got probability of direction change from start. So I paid attention to the games online, and what I saw was there was up to 5 different potential direction changes at most for a UFO flying across the screen. So I limit that hard for a UFO flying across the screen. He's going to make at most only 5 directional changes. Right there. Probability of directional change from the start. So you got the maximum directional changes, which are going to be 5. And then the probability on a per tick basis, which is basically 1 in 20, 5%, chance that they're going to actually do a directional change. Couldn't have it happen that much. There's at most 5 directional changes that are occurring. But every tick, every time this is drawn, there's a 5%, a 1 in 20 chance. Well, there's a good chance that, for 20 ticks, which is going to happen, basically once every second, you're increasing your odds dramatically, by the sheer volume. But this is on a one out of 20. There's a 1 out of 20% chance that this will actually change direction. That's actually what sets that right there on a per tick basis. So, other than that, so you got the UFO's position is active. Like I said, it's the same code as the ship, but this is where it gets a little bit different. So, should I change direction? I've got a Boolean value. So, if the UFO is active, should I change direction? I'm going to do a check. 1 to probability of direction change, which is, it's actually 1 in 5. So, yeah, 20% chance per tick. If that's equal to 1, then yes, it's a direction change. If it's not, then don't change direction. Now, what happens is on the probability of direction change, what I noticed that the longer that this would persist, the longer the UFO never not didn't change direction. So the longer the UFO stayed on the screen, the more percentage chance it had at actually changing its direction. So how I did this is maintain is probability of direction change is equal to, B, should I change direction? Well, yes, he's going to change direction this time. Now, will he change it again next time? There's going to be a low probability that he'll immediately change direction. And what we're going to do is maintain that by basically maintaining this variable. Probability of direction change start. So chances of him changing direction again is going to be 20% next time. It's going to be probably a little bit, that's a little bit on the high side. But looking on the screen, it actually turns out to work out pretty well. But every time that probability of direction change doesn't get fired, the likelihood of it happening increases on a per tick basis. So inevitably, it will get to a point where it will force a direction change. So, and that's exactly what's going on here. Next possible direction change is less than the ticks. Meaning the direction change is going to happen, and we've actually estimated when the next direction change happens. And should it change direction, or are we forcing out directional changes? Max directional changes. Oh yeah, so we can't have more than 5. Then change the number of directions and add 1 to that. Weird shit with numbers. What the hell was I thinking here? I know people like their go-to labels or hate them. Yeah, that's what I was going on here. I like practicing using abusing code. I've been in the industry way too long, and I realize that sometimes the structured way of programming isn't necessarily the best way. and sometimes just think about different approaches. And this is exactly what I did here. Direction for this. If the direction is less than 1 or greater than 3, so I was having times where, the randomizer is coming back with wrong numbers. It shouldn't be coming back with a 4. It was 1 to 3, but for some reason, I can't remember what I had happening here. But I'm kind of curious. No, I won't run it right now. Clearly, I had something. Clearly, I had some weird shit with random numbers going on that forced this to happen. And clearly, it was associated with one of these two different conditions being true, which is why I put it in there. So, in any case, when a directional change occurs, then change the direction one of 3 different directions. So it's going to be up, straight on, or down. And if it's down, it's going to be 45 degrees in that direction. So it'll be 45. So if it's basically parallel, it continues maintaining a right to left or a left to right, it will be 90. But if it's going up, it'll change to 45, and if it's going down, it'll be to 135. The angle will change accordingly. I noticed that the positional offset in the game itself maintained a left to right momentum velocity that was consistent regardless of how of its speed moving down. So there was never any left to right speed change, and that's what I ended up accommodating for this. For angular speed adjustment hack, what I do is I increase the speed if it's heading up or down, because the velocity changes. Basically, I'm going to fudge the velocity for the x, and the y will still get offset, so it will draw in the proper position on the y. On the x, it'll be accelerated, just to accommodate for the same speed going across from left to right. And at this point, another hack, the UFO always seems to be going in a straight line at the left and right most edges. So what I do is I draw a margin, and if it reaches that margin, it will discontinue directional changes at that point and maintain a constant 0 or a left or right without changing directions at the last minute. I never saw it change directions at the last minute, and this just ensures that. So then I move the positions y-axis and x-axis accordingly, the x and y positions accordingly. And then, in the case that the UFO has gone off the screen in either direction, left or right, at that point I call back into the canvas on that on UFO exit method. And like I said, that's a hack. There's definitely better ways to do this. I was getting towards the end and getting really kind of tired of this. So if he's still on the canvas, though, guess what? You draw him. There's the large one, points. There's a small one. And at that point, I could probably take that and shove it into a static buffer to make it a little bit faster to access and everything, but there's no reason for it. There's no physics that are associated with it other than collision detection, which is actually occurring within the main thing itself. And here's a spawn function, which we went through before, that does object collide, checking on this value being within a certain radius, and the trigger collision sequence, which basically sets this to being active and destroyed, not being active and destroyed. Now that's it with the UFO. So the last thing here, I want to make this quick, is sounds. And I took the approach of doing this in 2 separate ways. So the primary goal I had from the beginning was, and still is, to not leverage external assets in the form of a WAV file or external audio dependencies. And at first I was using in audio, which I ended up stripping out and replacing it with MCI send string commands. So I'm using those to initiate and call the commands. Now, I ended up first leveraging, there's some phenomenal code out there, and if you want to look at this, it's on GitHub. But these right here allowed me to generate sound waves. So I can actually generate a wave file. There was a sound class that I found on that one on Code Guru, and this one right here helped me understand the sound buffer itself. So that way, when I went to generate a sound, I can do something as simple as this: shape sound square. I can tell it the frequency, the duration, and the volume to play that, which basically sets the amplitude for that sound. And then all that does is return an array of shorts that are basically that sound in a square wave format. Now, the sound class itself, when it's started, I've got these different sounds that are associated with the application. Now, some of these are contained in the resources above, like I pointed out earlier. So that would be, for instance, destroyed asteroid small, medium, and large, and spaceship large and small, as well as a projectile. But the projectile right there. Now the thrust, the background music, and the pure tone, which I'm not using, are all created within this dynamically. So for each one of these, I'm storing the sound reference to the sound object in itself that creates an array of sounds associated with their location in a temp file on in the temp directory. Now, each one of those is added to that library through this. So instantiate sounds at the very beginning of the game. At this point, I create a pure tone and I generate audio in a wave file format with that call, and I call into it the pure tone. Now, if I go take a look at this, and the implementation is the same, other than the association that I have in the dictionary right there. Each sound is then able to be referenced by a key value from the enum, which you can see over here. So if I look at sound, so my sounds, library, you see here I've got the sounds, destroyed asteroid large. Well, that's contained within that dictionary. And I at that point play that sound, which is generated from this generate audio. And if you can see, this creates an object called an FX. And an FX is obviously going to have a method called play on it. So if you go take a look here at play, let's look for play with parens. So this here is contained within the Asteroids FX class, and from there I can actually directly play on it, and the play itself threads the call out to the MCI send string, and at that point it threads that call out, which is how I managed to get it going so fast. And at that point all it does is just basically opens that file, seeks the 0th position in it, and then plays it. Bails out when it's done. So, to get back to what I was doing, I know I'm going a little bit fast with this. On destruction, I close all, so I make sure all my MCI assets are cleaned up and everything. But here would generate audio. At this point, with the pure tone, for instance, I'll shape a sound square, with 255 as being the frequency, 1000 being, in milliseconds, which is 1 second, and then the amplitude is going to be 20,000. It's going to be really loud, square pure tone of 255. In the file name that I want this being saved as in the temp directory, so I can reference it if at a later time, or now if I want to, is going to be puretone.wave. I can make that sound tone be anything that I want to, but for me, for testing purposes, it made a lot more sense just name the files rather than having it be a temporary name. So, and I don't clean those up afterwards. I expect the user to clean up their temporary directories and temporary files. So hopefully you practice that. If not, I'm sorry. So like I said, the pure tone, I end up creating the sound dynamically. Shape sound square, and then shape sound thrust. So the square just basically creates a a square audio list of shorts that are converted to a byte array that are actually added to this range. The shape sound thrust again does the same thing, but it's got a little bit more complexity associated with it. The thrust it's based on a single tone frequency of 92 hertz. Duration is 500 milliseconds because of the way that I'm doing the threading and everything. I can make it sound like it's a much longer than it is on a repeat tape basis and everything. And all I do is I generate a little bit of a sine wave with it, adding in some random noise. So in between 200 to 1,000 amplitude is the amount of noise that I'm actually adding to it. So it plays that same tone. It just varies that tone and amplitude, and it varies it in basically every 150 samples. So since there's 44,100 samples per second, divide that by 150. So you're going to hear this warbly noise, which is how it comes out and everything. I'm shortening this by far because this took a hell of a lot more time, as you can see with some of my calculations here. I'm just like going, holy shit, this is such a pain in the ass to come up with in itself. Not perfect. Shape square wave does the same thing, but it's a square wave. So it basically takes the sine, and all it's doing is just basically a plus or -1. There is no amplitude, or there's the amplitude that goes into it, but it's only a plus or negative. It's not getting it's getting nothing but the ups and downs of the sine wave, and that's about it. So, with that, each one of these sounds, so those are the ones that are actually generated by mathematical function. These are read from the resources. Now, I would love to convert these at a later time to be mathematical functions, but I'm very new to sounds. So once I started diving into this and started looking at the projectile sound and comparing it and just going, how the fuck do I do this? I'm new to sounds, like I said, so this, to me, I'm just like going, I just want to get this thing in the bag. So what I did was I threw those assets as WAV files into the resource, and at this point I read those resources in and process them the same exact way that I do everything else. So I create a temporary file for each one, read it in Asteroids, read that into the buffer, and then once I've got that buffer, talking about those functions that I had up here, these articles I should say, that I took some of that code and I leveraged it to do this really nifty shit, which is basically building a WAV file in memory. This is really shit cool if you ask me. It takes the data as a byte array. Well, here's the crux of it right here. It creates a wave header that's in a very specific WAV file format. So I could show you in a browser, but I'm not actually linking that into OBS right now. It formats the header. It formats the chunk that comes to describe the data that's actually coming after it right there, and then it puts the data, which is the stuff that came from this up here. So we've got buff or SS data, wherever that was. Yeah, right there. And that SS data adds sample stereo data, SS data, and at that point, the data chunk, data, where do I get my byte array from? There's a buff. Oh yeah, that's right. No, wait. SS data. So data already has the range added. Where does the buff get added to it? Oh, there's no reason for it. Because WAV file is only formatted for two of them. So yeah, that's right. So these two right here, the shape sound square, shape sound thrust, returns a byte array or a short array of the data specifically, which is used to form a WAV file. And that WAV file is actually at this point stored here in this file name But depending on whether or not that data is coming from this dynamically generated WAV file or this pre-canned one that's pulled in from a resource, it will save whatever buffer actually contains something into that WAV file right there. And then at that point, I actually say, okay, we're not having that callback, so that canvas handle can go away. But got the cur sound that's associated with it and the path to that sound on the temp buffer. Now, if I go take a look at this down here, I'm no longer using that int pointer H window. I was actually trying to get callbacks working for something else. I was having all kinds of problems with sounds because I'm so new to it. But in any case, what this does is it says, okay, we've got an alias that's going to be associated with this sound file, and we're going to maintain that alias on a per sound basis. And what I'm going to do is basically create the MCI strings for each one. And all I'm doing basically at this point is opening the file. Where's the file get saved? File name. Oh no, it got created up above. Yeah, here's my failed attempt at getting a projectile to work. It just got ugly for the code. Shape sound thrust did pretty well, but pay no attention to my failures. Yeah, create wave file output. That actually creates the file in the temp path on disk, and all the FX does down here is basically say, take this, sound, and store this information, create the MCI strings, and then when we want to play it, when we stop it, we send the MCI strings immediately. So there is no threading for that. But when we want to play it, since we're wanting to do it async without any hesitation or anything like that, I thread each one of those calls out. So I just do that by saying, hey, play, if my thread is equal to null, then this is on a onesie twosie basis. The my thread will get called, but in some cases, like the projectile, there could be multiple threads called. And I just did this as a hack code to see if this would actually work. I was sure that when this got done, that it would actually stop playing that. I was wrong, but happily. I thought that this would actually get thrown into the garbage collection and would stop playing immediately, but I was wrong. So the cool thing is, I was able to do a delegate function call to play sound, and at that point, that opens up that thread. Start that thread and add it to my little thread pool. Oh, that's right, I did retain handles for it. So I've got a little handle for the thread pool right there, list of threads, with a maximum of 10. And at that point, I just iterate through the 10. And if we've got a thread that's stopped, I actually remove it from the pool, and then at that point, I never reuse a thread that's been started in there. I just basically remove it altogether to let it decay. So that's all I do. It's basically a play sound for every single sound that comes through, based on the text, the WAV file by file name that's actually contained in the temp directory, the seek string that's associated with each one, and the play string that's associated with each one. And if you go take a look at this play sound method, this is the method that's getting called for each sound in the thread. That will open it, that will sync it, and that will play it. And those calls are just called in order, and once it's done, it's done. There's no async, there's no delay, there's no nothing, because each one's a threaded call. So, if it is not playing, play sound. And this one prevents a sound from being played over and over again. So if the thread is equal to null, so UFO sound, for instance, or what else actually happens for a longer basis? thrust, is a good for instance too. Each one of those is only going to be triggered once and only once, and that's why this my thread thing is so important. So if it's any sound but the thrust, then go ahead and create that string and actually call that out. But if it's a projectile, run in here and actually play it as a threaded call and everything. Now, in the case that that thread, the thread state for that let's say we're playing the UFO and everything, you're calling into me, and that's currently playing. I was getting this really wickedly cool echo, because the UFO sound would be called hundreds of times, and all of a sudden I'm getting all these different threads, and it's just like, what the hell? That's really cool. So, in any case, this prevents it. So this basically says, okay, is it playing? If it's not playing, let's go take a look at the code on this one. Can fire next. All I'm doing is I'm taking the amount of time that this sound has. I'm calculating it in advance how long a song is, how long a sound is. Can fire. Yeah, media length and ticks. So I determine, okay, this is going to go for 820 milliseconds. I know when that's over that this can't go on past that. And I take a look at that, and I've got the I make that determination by right there and saying, okay, I'm going to add this amount in ticks. Now, you start playing the sound again, it cannot be played until it's over. It's 820 milliseconds, or 2 seconds in the case of some of the UFOs and everything. Now, you can stop it, you just can't start it up again. So, and this is what reinforces that. So that way I don't get my echo or anything like that. And the last stuff is the wave header stuff. So this is actually what's responsible for generating the wave file format information in fixed byte type format type stuff and everything. So as you can see down here, this is taking and literally saving this get bytes, and this is actually put out to the file later and put in binary, but this is a big, it takes everything, the format chunk, the format type, track samples per second, all this is contained in the wave file format itself. So if you take something like a debug editor or something that's a hex editor, I use HXD is something, or HexD is what I use, and it'll actually show you, the bits and bytes and you can actually look at this data that's physically stored in the wave file format. Convert that to the array, and at that point that actually gets output. This is a lot of my problem that I was having, was trying to find out the specific format and actually how to save it as a wave file. At first, I had used or tried using Sound Player, but Sound Player wasn't playing well with multiple sounds playing at the same time. Then I tried Media Player, and it didn't want to work at all. So then I converted over to InAudio, but I was getting pops and blips and all this other weird shit that was going on, and plus it's baggage, it's heavy. So once I finally said, okay, screw it, I'm going to try the MCI send string, method. At first it worked, but I was getting some wicked hesitations when I was like doing things like firing projectiles and that kind of stuff. Until finally I said, okay, what if I actually thread this into a separate call, and boom, it worked. It was freaking magic. I was just happier than shit and everything to see that that thing worked just like it was supposed to. So, anyways, long story short, this is the extent of the code for this, and as you can see, you know, um, I just converted it over to 2019. I've got to fix that little problem with the text appearing off to the side. It's not glitch free, it's not picture perfect. There's some little problems. If you could see, uh, these asteroids appear to be floating in pretty good directions, but a lot of times you'll get asteroids that for some reason they're floating in the same direction. It's like, what the hell? You know, uh, they'll be overlapped. You never see that in the original game and everything. So in the path of trying to actually explore and get the maintain the look and feel, of the original so much, with wildly different code behind the scenes to get it to work. I had a lot of fun, with this. It was cool. I mean, this is literally my first game I've ever created. I've worked in the corporate world for nearly 25 years and got out after after trying to commit suicide about 9 years ago and had a wicked drug addiction and everything. Was bored as hell in the corporate world. So this is actually fun for me. I had a good time for the first time in a long time doing code. I wish I can do the same thing with some of the VR stuff. I played with the Oculus, and I have an Oculus, and I've gotten some of the sample code going. I've done a considerable amount of C and C++ coding in it and everything, and all I can say is it's just a bitch to work with. So hopefully that type of stuff matures and becomes a little bit more simplistic and lets me, actually use C sharp, because I don't want to depend on Unity to do my development, because I just don't like the structure that they use, the format. I just want to be able to work just in code, and that's it. I'm a nerd. I'm old school. I'll be the first to admit it. But anyways, I hope you've gotten something out of this. Sorry if I drone on and everything. If you've got any questions, feel free to hit me up through comments here, or any number of different methods. It's on GitHub. You can find this all code. I'll put the links to the GitHub and the Sourceforge stuff down below. But yeah, hopefully you've enjoyed this, and hopefully you've gotten something out of it. I know I certainly did in my development efforts. Thank you very much, and have a good one.